Hi everyone, welcome to a new video of Concept Maths Online. So this live video is created for the 10th grade CBSE students. Today I will explain one of the important topic in the triangles chapter. You might have already covered in the schools, a basic proportionality theorem. Basic proportionality theorem. What do we mean by basic proportionality theorem? When we consider a triangle, if you draw one line segment parallel to any one side of the triangle, then this parallel line divide the other two sides in the same ratio. Okay, so this is the simple statement of basic proportionality theorem. Okay, so now this proof also included in your syllabus for the 10th grade. The proof is included for the basic proportion. So we need to know how to derive the proof for the basic proportionality theorem. Okay, so I'm going to derive in an easiest way. If you look at this, don't by heart the proof. Okay, just remember the techniques I use it to do the proof. Okay, so here we can see now one triangle is there. In the bigger triangle there is a smaller triangle is formed. Smaller triangle AD is there. Then one trapezium also there. Okay, BCED is a trapezium. You can see there is a trapezium. Okay, now I will make the two diagonals for this trapezium first. Okay, remember what are the procedure. Okay, I am doing here same thing you can follow, so you will get the proof within 5 minutes. Okay, within 5 minutes you can complete the proof. So you have to connect the two diagonals of the trapezium. Now you can see another two triangle is formed. Okay, BDE and CDE. Okay, CDE diagonal is formed. Now what I am going to do, this smaller triangle, you have to consider the bases AD and AE and write the area in terms of two bases. First write the area of the base AD. Next you have to make the area formula using the base AE. Okay, so if the base formula, we need to know the height. So you can draw the perpendicular to the respective bases. Okay, so we know how to draw perpendicular to the respective bases. Okay, AD and AE are the bases you have to consider one by one. So when you take the base AD, what is the perpendicular E? If you want, you can notate, let it be P. Okay, P is the point where the height intersect that base. Okay, height or altitude, we can say height or altitude EP. Now another altitude is drawn from D to the opposite side that intersected to Q at the line segment, on the line segment A. Okay, now you can write the area of triangle. We can denote it as area of AR of triangle AD is equal to half into when you consider this base. Okay, AD half into base into what is the height when you consider this base? PE is the height. Okay, PE is the height. Similarly we can write the same triangle area in the form of this base AE. Okay, so half into AE into what is the height when you consider this base? This QD or DQ is the height. Okay, so this is the first equation you have to make. Okay, area of the smaller triangle ADE, you can make it in the form of this base AD and the corresponding height PE. Also same area you can be expressed as AE base and the DQ height. Okay, so this is the first. Next you have to consider, I told you the other two triangles are formed here. BDE and CDE are formed. Okay, when you draw the diagonals of the trapezium, BDE and CDE are formed. Okay, so how to write the triangle BDE area using this EP height? Yes, EP height is drawn to, altitude is drawn to which base? BD of the triangle base. Okay, so you have to express the triangle BD area in the form of which altitude? PE, okay? So you can write area of triangle BD, okay? Previously we have done area of triangle AD. Now BD area you can write half into base you have to fix as the BD and altitude is same, okay? P, because altitude for this AD triangle is PE and altitude of this BD triangle also P, okay? Now, so this is another equation. So we have got equation 1, equation 2. Now you can make another area equation for the triangle BC with base C you can make. Base C Yes, next you have to write the area of CD, okay? CD with area of triangle CD you can express in the base C. When the base is C, what is the altitude? The height is the altitude drawn to that side from the opposite verticity, QD, okay? Or DQ is the altitude, okay? Now I am telling for this trapezium, this area, this CD area and the BDE area are same, equal. Why? They have the same base. They have the same base. If you fix this base and their altitude is remain same, because you can extend this base in this direction or this direction. So you can see this is the altitude. This height remains same when the base if you have taken T, okay? Because you can express area in the form of any side as a base, okay? When we express area DE base, these two are parallel lines, okay? So the height for this DE and the BDE will remain same, okay? When the height and bases remain same, area will be equal. So triangle, area of triangle BD equal to area of triangle CD, okay? So equation 2 you can equate, okay? Area of triangle BD equal to what? Area of triangle CD. So you can equate their RHS, okay? RHS half into BD into P is equal to what? Half into C into DQ, okay? So this you can equate, get the fourth equation, understand? Now from the first equation, we have already this equation, okay? Half into AD into P is equal to half into AE into DQ, okay? So we only need to divide this equation 1 by equation 2. What happened equation 1 by equation 2? The LHS PE half are same, okay? So equation, what we need to do? Equation 1 divided by equation 2. So what would you get? Half of it get cancelled. PE get cancelled. From RHS half of it cancelled. DQ get cancelled. Okay, what is the balance? AD by BD, okay? AD by BD is equal to AE by C, okay? So this is the proof for PPT, okay? So you can understand what is AD by BD, the ratio of division of the side AB, the point on this parallel line, okay? The D is the point on this parallel line segment to the third side that will divide in the ratio AD is to BD. Same ratio, AD is to BD equal to what? AE is to C. Same ratio, other sides will be divided, okay? The AC side will divide in the ratio A is to C. So this is the BPT theorem, has lots of application. The special case of BPT theorem is the midpoint theorem. You might have already named in the 9th grade. If you connect the midpoint of any two sides of a triangle, that line segment will be parallel to the third side, okay? Or we can also say, if you draw a parallel line to the any side of the triangle, okay? correct? So midpoint theorem also we can prove it. So remember, so this is the technique. Just remember how many triangles areas to be taken, okay? Area of the triangle ADE and area of the triangle BDE and area of triangle CD, okay? With which base and which altitude, okay? Which height you have to consider for that area. Then only you will get the exact proof, okay? So I think this is clear. If you have any doubts regarding this theorem and its proof, you can come to me, okay? Put it in the comment. I will give you the clarification. There is no doubt, okay? So I will be coming with new very interesting topics, okay? Important topics. So board exam is coming soon. So you have to start the preparation. This is the second half of this academic year, okay? So please be careful. Don't waste your time. So please prepare on time, okay? For every topic, the coming topic, second half will have the more weightage for the examination, okay? Because in the first half, you might have already learned some algebraic chapters, okay? Simple chapter. Now the geometry and the trigonometry, okay? Coordinate geometry and the mensuration chapter, okay? Those are the weightage chapter, high weightage chapter. So please focus on those chapter coming. So don't miss any concepts. So please follow my page and like, share with your friends and colleagues. Okay. Thank you for watching.